Hello there, and welcome to the Sleepless Scientist, a gentle corner of the universe where your thoughts can breathe, and curiosity turns into a quiet companion for the night. This evening, we're setting out to explore something that feels simple at first glance, yet holds the very rhythm of the cosmos itself: the speed of light. But before we drift into that endless glow, I'd be grateful if you could take a moment to like this video and subscribe. Only if these calm wanderings truly bring you peace. When you're ready, leave a comment and tell me where you're listening from and what time it is in your part of the world. It's always heartwarming to see this little constellation of night thinkers, each shining from a different corner of time. Now, dim the lights. Let the quiet hum of the room settle around you and allow the story to unfold gently. And if your mind happens to wander, let it. We'll still be right here, softly following the path of light together. Let's begin with a strange thought. You've likely heard it before: light moves fast. But not just fast like a speeding train or a racing car or a rocket streaking through the sky. Light travels at a speed that is, by the laws of the universe, unmatched and unmatchable. In the empty vacuum of space, it moves at exactly 299,792 kilometers per second. Not approximately, not generally, exactly. It's one of the most precise and sacred numbers in all of physics. But here's the odd part: it never changes. No matter where you are in the universe, no matter how fast you're moving, no matter what direction you're headed, light will always reach you at the same unwavering pace. If you chased it at nearly the same speed, it wouldn't look any slower. And if you ran away from it as fast as you could, it would still catch up at the same steady beat. It doesn't hurry, it doesn't lag, it just is. This is no ordinary motion. This is not like a bird flying or a car cruising along the highway. Light doesn't merely move through space, it weaves space together with time. It's the gentle seam that binds distance and duration into one continuous fabric, the very fabric of space-time itself. You may have heard that phrase before: space-time. It's not just poetic, it's precise. Because space and time do not exist as separate things. They twist together, lean on each other, and flow into one another. And at the center of their dance is light, or more accurately, the speed at which light moves. Imagine, just for a moment, that light moved faster, or slower. The entire rhythm of the universe would shift. Planets wouldn't orbit the way they do. Stars wouldn't shine the way they do. Even your own thoughts, which depend on electric pulses racing down your nerves, would unfold differently. If light was slower, it might take just a little too long for your mind to assemble the world around you. If it were faster, your body's chemistry might fall out of sync. Reality, in all its delicate choreography, plays to the beat of light's constant speed. Now you might wonder, why light? Why is this quiet traveller the one thing the universe holds steady? Why not gravity or mass or temperature? Well, there's a kind of elegant mystery in that. Light, unlike almost everything else, has no rest frame. It never stops. It has no mass to slow it down. It is the great messenger, slipping between galaxies, bouncing off mirrors, dancing through rainbows, never once needing to pause or breathe. And because of that, light becomes the standard for all other motion. To measure how fast anything moves, we compare it to how fast light would move in the same space. We even define our very notion of a meter. Yes, the meter on a ruler or tape measure, based on how far light travels in a tiny fraction of a second. Not by a rod in Paris, not by some ancient standard, but by the distance light quietly slips across in an eye blink of time. This is why the speed of light isn't just a number, it's the rule book, the rhythm, the cosmic pulse that tells everything else how to behave. It doesn't just move, It defines how movement is even possible. Now think about this. If light takes time to travel, then when you see something, anything, you're seeing it not as it is, but as it was. Not a second ago perhaps, but a fraction of a fraction. Still, never now. When you look at the moon, you're seeing light that left it a little over a second ago. The sun, that light took about 8 minutes to reach your eyes. Every sunset you've ever watched was already finished before you saw it. This delay isn't an error, it's not a flaw. It's how the universe works. Everything you see is a memory, a soft echo of a photon's journey, arriving at your retinas and turning into thought. We live inside a universe made of old light, each ray a whisper from the past, gently knocking at the door of your awareness. And it's not just stars and planets, even the people around you, the room you sit in, the device you're listening on, all of it is bathed in light that left moments ago. Your entire field of vision is a tapestry of recent departures, so the next time you blink, remember, the light entering your eyes has travelled a road. It has slipped through time to reach you, and what you see is not the present, but a gift from the past wrapped in brightness. This is where we begin, at the edge of perception, with a gentle realization that nothing we see is happening now. That light, the universe's quiet courier, brings us stories delayed but never untrue. And so we start our journey into light, not with equations but with wonder, not to chase it, but to walk beside it for a while. Time is a slippery thing. You might think you're living in the present, sitting there, listening to these words, feeling the weight of your body sink into the bed or the couch, watching the slow rise and fall of your breath. But in truth, you are always a little behind. A few milliseconds behind reality, maybe more. Not because you're inattentive, but because your brain is simply catching up. The present, as it turns out, is not something you live inside, it's something you reconstruct. Let's start with something small. When you look at a candle's flame, you're not seeing it as it is right now. You're seeing the light that left it a few nanoseconds ago. The distance from flame to eye is short, but the light still takes time to get there. Not much time, of course, but some. Then that light must bounce through your eye's lens, land on the retina, be converted into electrical signals, sent down the optic nerve, interpreted by the brain, cross-referenced with memory, and finally rendered into a mental image. Ah, a candle. By the time you consciously perceive the flame, it has already flickered slightly differently. A few thousandths of a second may have passed. You're not looking at the world, you're looking at its echo. And the brain, wonderful as it is, does not rush. It is not in a hurry. It likes to take a moment, stitch things together, smooth out gaps, and make sure what you see feels continuous. But this process introduces a delay. Studies in neuroscience suggest that what we perceive as now is actually a small window of time, an average, a smoothing of recent input, about 80 milliseconds long. You don't experience events as they happen, you experience them as they've just happened. Like hearing thunder roll after the lightning, except it happens with everything. Even your sense of self, that quiet voice narrating your day, is built on delayed information. The world you walk through isn't live, it's playback. And because light takes time to arrive, the further something is, the more delayed it becomes. Look at a mountain in the distance, and you're seeing it not a second ago, not a minute ago, but maybe a few dozen microseconds in the past. Stand outside at night, gaze at the stars, and suddenly you're seeing light that began its journey hundreds, thousands, even billions of years ago. Light from stars that may not even exist anymore. You are, in a very real sense, looking at ghosts, beautiful ones, silent ones, still shining. This makes astronomy a kind of time travel. Telescopes aren't just seeing space, they're witnessing history. Every photon collected by a mirror on Earth is a message from the past, a whisper of ancient fire. The further we peer, the older the messages become, until eventually we reach the faint scattered glow left over from the birth of the universe itself, the cosmic microwave background. It's not a glow we can see with our eyes, but with sensitive instruments, we can feel it, like a warmth radiating from a long-dead campfire. But this doesn't only apply to stars, it applies to people. When you look into someone's eyes, you're seeing light that left them a moment ago. The smile you see is already slightly outdated, a snapshot from a millisecond in the past. We don't often notice this, of course. Human-scale delays are small, but they're always there. A friend's expression, a child's laugh, the glance of a passing stranger, each one arrives in your awareness after a subtle delay. Like reading a letter written just a moment before, you're never seeing things happen. You're always watching them finish. Now imagine for a moment that you could slow everything down, that you could perceive each photon as it arrived, frame by frame, like single droplets of water falling from a faucet. You might see the world not as a flowing river, but as a series of gentle pulses, each one a glimpse into the immediate past, each one a gift from what was. And this, in its own quiet way, is profound, because it means you're always living in memory. Not long ago memory, not childhood nostalgia, but fresh, luminous, immediate memory. Light doesn't let you see the present. It lets you remember it as it happens. There is a softness to this idea, a kind of poetic delay built into all things. You're not late to your life. You're simply receiving it through the medium of light, one shimmering moment at a time. The stars don't rush to be seen. The world doesn't demand to be perceived instantly. It takes its time, and so do you. This delay gives space for thought, for reflection, for the space between cause and awareness, between movement and realization. It means you're not a machine, reacting in real time, but a conscious being, responding with grace, with perspective, with a slight pause that allows beauty to bloom, and it invites you to consider, if everything you see is slightly behind, then where is the true now? Is there such a thing? Or is now just a concept, a convenience, a rhythm we've chosen to agree on? Maybe the only now that matters is the one we feel together, the shared pulse of attention, the hush between words, the moment we breathe in at the same time. And perhaps light, with all its speed, isn't about rushing forward, but about gently bringing the past into the present. Not as a burden, but as a blessing. Not to trap us in memory, but to remind us that we are made of it. So tonight, as you rest your eyes and the world begins to blur, remember that what you saw today was already gone when you saw it. And that's okay. Because even delayed, even distant, the light still found its way to you. Quiet, graceful, and always just in time. There's a comfort in cause and effect. You flip a switch, and the light turns on. You speak, and a voice responds. Each moment seems to follow from the last like stepping stones across a stream. Even when the world feels uncertain, we trust that causes precede consequences, that actions lead to results. But why is that? What makes the future follow the past and not the other way around? The answer, quietly and precisely, is light. Light doesn't just illuminate the world, it organizes it. It defines what can influence what and when. In the universe, nothing moves faster than light. Not thoughts, not gravity, not even the wildest science fiction spaceship. This speed limit isn't just a cosmic courtesy. It's what holds together the order of time. If you could go faster than light, you could, at least in theory, send a message into the past. You could affect something before you caused it. The stream of time would ripple backward and everything would unravel, but you can't. Not because it's hard, not because we lack the tools, but because the very geometry of the universe won't let it happen. Physicists describe this with something called a light cone, which sounds more like a dessert than a law of nature. But it's a beautiful idea. Picture yourself standing in a dark field. In your hand is a lantern. When you switch it on, the light spreads outward in all directions, creating a sphere of illumination that grows with every passing second. That expanding bubble of light represents all the places your presence can reach. It marks the boundary between what you can affect and what you can't. That sphere in physics is your future light cone. Now reverse the idea. Imagine all the light arriving at you in this moment, from stars, from lamps, from people's faces. Those beams define your past light cone. Everything inside it is something that could, in theory, have touched you. Everything outside it, it's not just far away, it's beyond casual contact. It may as well be in another story entirely. This is more than a metaphor. It's how the universe works. Every event, every tick of a clock, every heartbeat, every photon bouncing off your skin exists within a network of light cones. They ripple and intersect, defining who can talk to whom, who can see what, and when anything can matter to anything else. If something happens outside your light cone, it is unreachable, not delayed, not hidden, just untouchable. A person a billion light years away could wave a flag right now, but that wave won't reach you for a billion years. As far as your reality is concerned, it hasn't happened yet. This is the secret framework that protects the flow of time, not just as a sequence of moments, but as a map of connection. Light speed carves that map, draws its edges, and ensures that events fall into place with structure and coherence. Let's say you wanted to break this rule, to send a signal faster than light, to cheat the universe a little. The moment you try, strange things begin to happen. From your point of view, it might feel like you're sending a message forward in time, but from someone else's perspective, depending on how they're moving, it might look like that message arrived before it was sent. The sequence flips, cause becomes effect, and effect becomes cause. The structure collapses. That's why nature is so strict about this limit. It's not about speed, really. It's about logic. The speed of light doesn't just measure how fast things move. It defines what order things happen in. It ensures that every story has a beginning, a middle, and an end, no matter who's reading it. And this brings us to something quietly humbling. You and I right now are connected only because light allows it. This message, these words, your thoughts forming in response, all of it depends on photons travelling from screen to eye, from eye to brain, from brain to memory. If those photons travelled faster than light or slower or inconsistently, meaning itself would dissolve. Time wouldn't be a thread you could follow, it would be a tangle. We could not agree on what happened, and without agreement there is no reality, only noise. But light is not noisy. It is precise. It is constant. It does not improvise. From the beginning of the universe to this very moment, it has obeyed the same rule. No faster, no slower, just steady, silent, unstoppable. This constancy is what makes science possible, what makes communication possible, what makes consciousness in many ways even comprehensible. Because light defines not only how fast things travel, but what before and after even mean. So the next time you open a window and see a bird fly past, or glance at the stars overhead, or catch a friend's eye across a room, remember that you're not just seeing something, you're receiving it at the only speed the universe permits. You're within its cone, connected, touched by light, and everything else, what you haven't seen yet, what you may never see, remains outside, not forbidden, just waiting. And in that waiting, in those unreachable places, there are still stories unfolding, events outside your light cone, not unknowable forever, but only for now. One day, their light may reach you, and when it does, you'll be changed by it, gently and completely, the way light always changes what it touches. Until then, you live within your cone. You see what you're allowed to see. You feel what has reached you. And the universe, with all its chaos and brilliance, holds itself together with one quiet rule. Nothing moves faster than light, not even truth. If you've ever stood still in a quiet room with nothing but the ticking of a distant clock to keep you company, you may have felt it, that strange sensation that time flows evenly, that space sits still, and that movement is something added on top of that stillness. It's a comforting illusion, but the universe, as it turns out, isn't nearly so cooperative. The stillness is only apparent. Beneath it lies a gentle contortion, a slow, relentless bending of space and time, performed in perfect harmony so that one thing remains forever unchanged: the speed of light. It might seem like a simple number, just under 300,000 kilometers per second. We use it to calculate distances between stars, to explain how fast messages travel, even to define what a meter is. But this number, c as physicists write it, is not just a measurement. It's a constant that refuses to budge, a law written into the structure of reality. To understand why that's so remarkable, imagine a different kind of world. One where speeds behave the way we expect. If you throw a ball on a train moving forward, the ball's speed, relative to the ground, should be the speed of the train plus the speed of your throw. That's common sense. It's how things work in daily life. If you shine a flashlight from the front of a moving train, it seems natural to assume the beam speed should be the speed of the train plus the speed of light. But that's not what the universe does. Instead, light says, "No, I will not add or subtract. I will not adjust." Whether you're on a train, a rocket, or standing still, the beam of light leaves you at exactly the same speed. Always c, never more, never less. This baffled scientists for a long time. It broke their intuition. But then came Einstein, who saw that the problem wasn't light, it was our expectations. If light speed is constant for everyone, then the only way to make sense of that is for time and space themselves to stretch and shrink. And so, with astonishing calm, the universe obeys. This is the heart of special relativity. To preserve the constancy of light, time dilates and space contracts. If you move quickly, your clock ticks more slowly compared to someone at rest. If you observe someone else's clock while you're in motion, you'll think they are the ones slowing down. Both are right. Because the rules bend to protect the one thing that does not, the speed of light. But what does that mean, really? It means that time is not universal. There is no single ticking clock shared by all. Instead, each observer carries their own clock, moving at their own pace, determined by their motion. And all of these clocks are valid. There's no master time to correct them, no hidden rhythm to override their local tick. Even space gets involved. When you move fast, distances shorten in the direction you're travelling. This is not because your eyes are tricked. It's because the space itself reshapes to keep the laws consistent. Time slows down. Space collapses. And in the middle of all this quiet chaos, light glides forward, unbothered. This reshaping of reality isn't limited to abstract equations. It affects real machines, satellites, and people. The GPS system in your phone depends on the careful correction of time dilation. Satellites orbit Earth at high speed and experience less gravity than people on the ground. Both of those effects, motion and gravity, cause their clocks to tick differently. Engineers must account for these differences to make sure your directions don't send you into a lake instead of a left turn. In that way, relativity is not just real, it's embedded in our daily lives. The universe bends time so you can find your coffee shop. But this bending isn't violent. It's not like space is ripping or time is warping dramatically in front of your eyes. It's subtle, gentle, like a soft stretching of fabric under weight. You can't feel it, but it's there. Every time you move, even slightly, your perception of time adjusts. Your measure of distance shifts. It's imperceptible in everyday life, but not because it isn't happening. It is. You're just used to it. Your body accepts the illusion of stillness because the distortions are so small. But if you could move faster, approaching the speed of light, you'd see the shift. You'd feel the strange poetry of time slipping away from you and space narrowing like a tunnel. It's tempting to think of light as a thing that just moves fast, but really, it's the thing that holds still while everything else moves around it. It's the reference point the universe uses to balance its equations, and to protect that balance, the cosmos will twist itself into new shapes. So why is light so privileged? Why does it get this special treatment? The answer lies in its nature. Light has no mass. That means it doesn't rest. It doesn't age. It doesn't experience the passage of time. From the moment a photon is born, maybe inside a star or a spark or the surface of your phone, it begins its journey, and it ends it in what to the photon is the same instant. There is no time between. For us, light may take billions of years to reach its destination. For light, there was no journey at all, and so the universe keeps its promise. Every observer, no matter how fast or slow, no matter where or when, will measure light's speed as the same. To make that happen, the universe doesn't change light, it changes you. And that is perhaps the most beautiful idea of all, that the cosmos bends around a single truth, and in doing so it teaches us that nothing is truly still, that time is not rigid, and that reality itself is woven not from fixed hours or rigid meters, but from a single, unwavering rhythm, the speed of light. Try to imagine, if only for a moment, what it would be like to become light. Not to see it, or to follow it, or even to chase it, but to be it. To surrender mass, to dissolve into motion, and to become a beam. A photon, as it's called in the language of physics, the smallest possible packet of light. No rest, no waiting, only travel. But this journey would not be what you think. Because for a photon, there is no during, only the departure and the arrival, pressed into a single seamless moment. This might sound strange or abstract or impossible to imagine, and that's because it is. The world of light is not the world you know. It doesn't unfold in seconds or minutes. It doesn't stretch across time. It skips time. Or, perhaps more accurately, it ignores it. From our perspective, light takes time to move. We see it travel across rooms, through windows, between stars. We measure its speed. We marvel at how it takes 8 minutes to reach us from the sun, or 2 million years to arrive from the Andromeda Galaxy. But to the photon itself, if it could be said to have a perspective, none of that happens. Because in the language of relativity, photons experience no proper time. Proper time is the time measured by a clock moving along with you. It's your own personal timeline. The seconds you feel pass as you walk or sit or breathe. But photons move at the speed of light, and at that speed, time doesn't just slow down. It stops. It vanishes entirely from the photon's world line. That means that, in its own frame of reference, a photon doesn't travel in the way we do. It doesn't experience movement across distance over time. The entire voyage, from being emitted, say, by the surface of a star, to being absorbed by your eye, is to the photon a single point. No time passes. There is no in-between. This is not an illusion or a metaphor. It's a literal consequence of Einstein's equations. When an object with mass accelerates toward the speed of light, its experience of time slows relative to an outside observer. The faster it goes, the slower time flows, and if you could reach the speed of light, which you cannot, but if you could, time for you would freeze, not just slow, freeze. But because you have mass, this is forever out of reach. You can get close, but never quite there. Photons don't have this limitation. They are born massless. They are never at rest. They don't accelerate toward light speed. They are light speed. And so, for them, time is meaningless. That's hard to grasp because everything we know is soaked in time. We age, we wait, we remember. Even when we do nothing, time trickles past us. But photons live outside that current. They are like stones skipping across the surface of a river, never touching the water below. They don't move through time. They exist along the edges of it, outlining what is visible, what can be known. And this strangeness has consequences. Every beam of light you see, whether it's from a candle, a screen, or a galaxy, is telling you not just where it came from, but how long it took to get here. Not from its point of view, of course, from yours. You see delay. The photon does not. You see journey. It sees unity. And so light becomes a kind of bridge, not just across distance, but across perspectives, between a timeless carrier and a time-bound observer. What's even more remarkable is how this property, this zero-time experience, is what allows light to define your experience of time. It's almost paradoxical. The thing that does not live in time is what lets you measure it. Your clocks, your rhythms, your understanding of before and after, all rely on the steady behaviour of something that has no before and no after of its own. Consider this. When you look at the stars, the light entering your eyes left those suns millions or billions of years ago. From your perspective, it has travelled across vast chasms of space and epochs of time. But from the photon's perspective, that journey had no length, no delay, no middle. It began and ended in the same breathless instant. It was emitted and then absorbed, and nothing existed in between. Now think about that in human terms. Imagine if you could go somewhere, across the world, across a galaxy, and it felt instant. Not fast, not rapid, instant. As if you were already there the moment you began. That's what light experiences, or rather, that's what it is. Of course, this idea breaks down if we push it too far. Photons can't think. They don't carry clocks. They don't tell stories. They aren't conscious of their existence. But that doesn't mean they have no story to tell. Because every time light strikes your skin, or a telescope mirror, or a blade of grass, it brings with it a record, a distance crossed, a time endured, a message delivered. You receive it, you decode it, you feel it, you dream because light showed you colour, you remember because light once painted an image on your eyes, and so the photon, silent and thoughtless though it may be, becomes a kind of poet, a traveller without feet, a messenger without voice, speaking in wavelengths and energy, telling you, I was there, now I am here. And for me, those are the same. To ride a photon is to leave time behind, to forget waiting, to dissolve movement into arrival. You can't do it, but you can imagine it. And maybe, in those quiet moments when the world slows down, when you sit still and breathe softly and think of starlight crossing the ages to reach you, you get just a glimpse of what it would feel like to be the bridge between two moments with no seconds in between. You've likely been told that light is a wave, or perhaps you've heard just as confidently that light is a particle. The truth is, both are correct and both are incomplete. Light, like so many things in the universe, resists our neat categories. It does not settle quietly into a single identity. Instead, it flickers between forms, sometimes behaving like a ripple spreading through space, and at other times arriving as a precise countable unit, a photon. It's one of the strangest truths in physics, and one of the most beautiful. Because light, in its quiet defiance of clarity, reminds us that not everything needs to be either or. Sometimes the answer is simply yes. Let's start with a wave. Imagine a pond on a windless day. Toss a pebble and ripples spread outward, circular, rhythmic, steady. This is how light behaves when no one is watching. It spreads, oscillates, creates patterns of interference. You can measure its wavelength, the distance between peaks, and its frequency, how often those peaks arrive. Longer wavelengths make red light, shorter ones make blue. These waves don't need water. Light's ripples are made of electric and magnetic fields, weaving through empty space, pulsing at right angles to one another, moving forward at the speed of light. It's like a dance between two invisible partners, stepping in rhythm across the cosmos. But then there's the other side. When light strikes a metal plate and knocks electrons free, or when it lands on the retina of your eye and sets off a neural signal, it doesn't arrive as a wave. It arrives as a packet, a discrete quanta, a particle. It behaves not like a gentle ripple, but like a dart, hitting with precision. This is the photon, light's particle nature. Not a speck of dust, not a tiny marble, but an indivisible burst of energy, delivering just enough to do its job. For a long time, physicists struggled with this contradiction. How could something be both spread out and precise? How could it interfere with itself like a wave and yet land like a particle? The answer, or perhaps more honestly, the lack of an answer, came into focus with one of the most elegant experiments ever devised, the double slit. Imagine this. You set up a screen with two narrow slits side by side. You shine light through them, and on the wall behind you don't see two bright spots. Instead, you see a striped pattern. Light and dark bands, as though the waves are overlapping, cancelling out in some places and reinforcing in others. This is classic wave behaviour. It's what you'd expect if water passed through the slits. But then you do something odd. You dim the light until it's sending just one photon at a time. Now, you'd expect those single particles to land in two straight lines, like marbles tossed through two holes. But they don't. Over time, the same interference pattern appears, as though each photon isn't just going through one slit, but somehow both, as though it interferes with itself. And then, if you place a detector at the slits to find out which one the photon goes through, the interference disappears, the pattern vanishes, light behaves like a particle again. It chooses a slit, it lands predictably, it stops being mysterious. It's almost as if the act of watching changes the outcome, as if light, aware of being observed, shifts its performance, like an actor who behaves differently when someone enters the room. Of course, photons aren't conscious, they don't think. But the math tells us this: the moment you gain which path information, which slit the photon went through, the wave-like behaviour vanishes. What this means, in deeper terms, is still up for debate. Some interpretations say the wave was never real, just a probability. Others suggest the world splits into possibilities. Some simply shrug and say, we can calculate the outcomes. That's enough. But no one pretends it's simple. Light defies simplification. It is not just a wave. It is not just a particle. It is something else, something in between or beyond. And this duality isn't unique to light. Electrons, protons, even atoms can show similar behaviour. The universe, at its smallest scales, is built not from certainty, but from shimmering probabilities. Yet you don't need to be a physicist to feel this mystery. You've seen light paint waves on water. You've watched shadows flicker across a wall. You've seen dust hang in sunlight, dancing in stillness. You've stared at stars and felt their shimmer, not just with your eyes, but with something quieter inside you. You've experienced light. And that, more than equations or diagrams, is what matters. Because in the end, light isn't asking to be understood. It's asking to be witnessed. It doesn't demand clarity. It offers presence. Whether it's arriving as a wave, spreading gently through a window at dawn, or landing as a photon on the back of your eye, carrying the colour of a rose or the glint of a loved one's smile, it is there. Real, immediate, mysterious. And perhaps that's why we're drawn to it. Not just for illumination, but for companionship. Light, in all its strangeness, meets us where we are. It touches both the scientific and the sacred. It humbles us with its paradox and comforts us with its constancy. It flickers at the edge of understanding like a candle in the dark, asking no questions but inviting all of them. So the next time you see sunlight spilling across the floor or a single star blinking in the sky, remember that what you're seeing is not one thing or the other. It's a whisper from a universe that contains multitudes, a wave, a particle, a mystery, and somehow all of it at once. There is something quietly miraculous about the way light speaks, not in words, but in tones, in warmth, in shimmer and hue. It whispers in red, sings in blue, hums in the yellow of a summer afternoon, and breathes in the silver hush of dawn. The world is never silent because light is always talking, and once you learn its language, you begin to see that colour is not just decoration, it is communication. Let's begin with something simple, something you've seen 1,000 times but maybe never truly met: the rainbow. A spectrum stretching from red to violet. It isn't made of different kinds of light, but different frequencies of the same thing. All light is vibration, a wave pulsing through space, and the only difference between one colour and the next is how quickly that wave moves up and down, its frequency, or how long each full ripple stretches, its wavelength. Red light has the longest wavelength in the visible spectrum. It moves gently, slowly. It's the warmest and softest of the visible waves. Blue light, by contrast, has a much shorter wavelength. It oscillates more rapidly, more energetically. It arrives with a sharper punch. These differences are not just visual, they're physical. The colour you see is a direct expression of the energy that light carries. This energy defines more than what's beautiful. It shapes what we feel, how we see the world, and even how we age. Sunlight, for instance, contains many kinds of light, some of it visible, some not. The warmth you feel on your skin is mostly infrared radiation. Just beyond the red edge of the visible spectrum, it's not visible to your eyes, but your body feels it as heat. It is gentle, like a warm breath on your face. On the other side of the spectrum, beyond violet, lies ultraviolet. Its waves are short, fast, and powerful. So powerful, in fact, that they can damage cells, strip electrons, and fade paint from a wall. It's the reason your skin tans, or burns, after a long day under the sky. You can't see ultraviolet, but your body knows it's there. It senses it through change. Between those two invisible ends, in the narrow sliver we call visible, lives the spectrum of human experience. We don't just see colours, we respond to them. Red signals heat, urgency, attention. Blue speaks of distance, cold, calm. Yellow carries the glow of firelight and ripe fruit. Green is growth and life and rest. Our brains evolved in a world saturated with light, and over time, we learned to read its cues as if they were feelings. There's more to it than emotion. There's physics too. Light's energy is tied directly to its frequency. Higher frequency means higher energy. That's why blue stars are hotter than red ones. It's why fire changes colour as it grows hotter, from red to orange to white to blue. The flame tells a story about temperature, simply by shifting its hue. You've seen this even in the sky. At midday, when the sun is high, the light is white or blue tinged. It's shorter, higher energy waves reaching us more directly. But at sunrise or sunset, the light must pass through more atmosphere, which scatters the blue and leaves behind the longer, redder waves. The result? That slow, golden light that spills across floors and sets windows aglow. That warmth isn't just emotional, it's spectral. You're feeling the world's rotation, translated into colour. And then there's the way light reveals temperature directly. Infrared cameras, for instance, don't see what your eyes do. They see heat, a handprint left on a table, slowly fading. The soft glow of a living body, the invisible warmth rising from a sidewalk. These are all part of the electromagnetic spectrum, just beyond red. But they tell a story all their own. A story of life, of motion, of memory etched in temperature. It's not just cameras that do this. Your own skin can sense light in its own quiet way. Close your eyes and turn your face toward the sun. You'll feel it. Not see it, but feel the light as warmth, as pressure, even as emotion. Your senses overlap in these moments. Sight blends with sensation. Colour becomes more than visual. It becomes personal, and it works in reverse too. Your emotions can change how you perceive light. A grey sky feels colder if your heart is heavy. A golden hour can feel like a balm if you're carrying joy. Scientists have found that colour perception can shift with mood, and that certain wavelengths of light can affect circadian rhythms, alertness, even mental clarity. Blue light wakes you, orange light soothes you. The world is always casting light, but how you receive it changes everything. This is why we light candles at dinner, why we paint rooms in soft greens and blues, why emergency signs glow red. We are responding not just to brightness, but to frequency, energy, vibration. Light is the language of mood, of signal, of rhythm, and all of this comes from a simple truth. Light is energy, and that energy is not silent. It hums, it warms, it colours, it speaks to us constantly. In every sunrise and every screen, in every firefly and every fading shadow, light is telling us something. We just need to slow down enough to listen. So the next time you sit beside a window and watch the afternoon shift toward dusk, notice how the colours change, how the shadows grow longer and softer, how the blue begins to fade into gold, then orange, then quiet. That's light, speaking in its own slow way, reminding you not only of time's passing, but of presence. You are here. You're bathed in colour. You're made in part from this very glow. You may not realise it, but you are glowing right now. Not metaphorically, not figuratively, literally. Your body, at this very moment, is quietly radiating light. It is invisible to your eyes, too gentle, too soft to be seen, but it's there, drifting outward in long, slow waves. This glow doesn't come from effort. It isn't something you do. It's something you are. Your skin, your breath, your fingertips, they all emit infrared radiation, a kind of light just beyond the red end of the visible spectrum. If you stood in a dark room with an infrared camera, your outline would shimmer in warm shades of orange and yellow. You'd leave glowing handprints on the furniture. Your face would shine softly. You'd look like a candle made of breath and memory. This glow is not a special effect. It's a natural result of being alive. Every object above absolute zero, the coldest possible temperature, radiates some kind of light. The hotter it is, the more it radiates. Stars, of course, burn brightly in visible light. A stovetop might glow red. A cat sleeping on a windowsill will radiate gentle warmth. And you, simply sitting still, give off enough infrared energy to be seen by a machine and felt by someone standing close. But your glow is more than heat. It is a quiet echo of something older, something stellar. Because before you emitted your first photon, you absorbed countless others, from the sun, from food, from warmth, from the flickering sky. Plants take sunlight and trap it in their leaves. That sunlight becomes sugar. That sugar becomes fruit. That fruit becomes you, your cells, your motion, your thought, light transformed into matter. Then, over time, returned again as motion, as warmth, as action. You're not just a glowing body, you're recycled starlight. And it doesn't end there. Every breath you take contains molecules shaped by sunlight. Every thought you have requires chemical signals powered by energy that once lived in the glow of the sun. You walk around not just powered by light, but composed of it. A pattern of particles arranged by long ago radiation, moving, shifting, remembering. Even in complete darkness, this light continues. You don't need to be seen to shine. You don't need to move to radiate. A sleeping body glows just as steadily as a waking one. In fact, infrared imaging is sometimes used to monitor sleep patterns by watching the changes in heat as bodies rest, turn, dream. Other creatures take this glowing further. Fireflies, jellyfish, deep sea fish. They glow with visible light, using chemical reactions to create their own luminance. This is called bioluminescence, a dance of molecules that produces actual shimmering light. They use it to attract mates, to warn predators, to speak across the abyss. In the deepest parts of the ocean, where sunlight never reaches, life still glows. Not as a reflection, but as an act of self-expression. You may not shine in visible light, but in the quiet spectrum just beyond human sight, you're not so different. You too emit. You too express. Perhaps not with colour, but with warmth, with presence, with quiet radiance that the world in its own way notices. And perhaps this is why we find light so comforting. Not just because we see by it, but because we sense somewhere deep inside that we are part of it. That we are made not only of carbon and water, but of energy that once moved freely through the sky. That we are not separate from sunlight, but a continuation of it. This glow even leaves traces. Infrared fingerprints, thermal echoes, the warmth of your palm lingering on a chair, the heat of your steps fading along a path. You're always leaving behind a gentle trail of radiance, not bright, not blazing, but real, measurable, a soft reminder that you passed through, and in return the world gives back its own glow. The earth itself radiates warmth into space, the moon reflects sunlight into the night. Even the cold, empty darkness of space is not truly dark. It hums with the faint microwave glow of the early universe, relic light from a time when the cosmos was still young and hot and full of fire. That glow too is part of the story, part of the light that never stopped moving. So when you feel the warmth of your hand against your face, or the heat of another person standing close, remember that you are not just exchanging comfort, you're sharing light. You are made of waves that extend outward, invisibly, softly, constantly. You're never truly still, never truly dark. Even in silence, even in sleep, you glow. And perhaps that's why moments of deep connection often feel warm. A hug, a conversation, a shared glance across a room. There is science there, yes. Body heat, proximity, infrared radiation. But there is something else too. A feeling that you are not just with someone, but in resonance with them. Like two stars caught in each other's light. Like two flames brushing gently in the dark. So as you drift towards sleep tonight, consider this. Even in the deepest quiet, you are glowing. Not for anyone to see, not for anyone to measure, but simply because you exist. You, the soft engine of memory and breath, are made of energy that once lit the skies and will someday light the world again. You are light at rest. You live inside a rhythm. Every breath, every heartbeat, every blink follows a beat so familiar you hardly notice it. Time feels like the great constant, steady, fair, ticking forward 1 second at a time. But that rhythm, as comforting as it seems, is not fixed. It can stretch, it can bend, and once you begin to move quickly, very quickly, that steady tick begins to drift. Time itself begins to loosen. This may sound impossible. Time, after all, feels universal. A second is a second, no matter where you are, right? But the universe, in its quiet precision, disagrees. Let's say you're holding two identical clocks. One stays with you on the ground. The other, you place aboard a jet circling the globe at high speed. When the plane lands and the clock is returned, something subtle but astonishing is revealed. The airborne clock, identical in every way, has ticked slightly slower. It has fallen behind. Just by moving quickly, it has aged less. This is not a trick of instruments. It is not a malfunction or a misreading. It's a real effect. A manifestation of a rule first uncovered by Albert Einstein, woven deeply into the fabric of reality. The faster you move through space, the slower you move through time. This is time dilation, one of the most surreal gifts of special relativity. And it isn't just a thought experiment, It has been measured again and again with exquisite precision. Atomic clocks, among the most accurate instruments ever built, have been used to confirm this effect at various altitudes and speeds. Time doesn't just feel different in motion, it is different. The reason is elegant and deeply poetic. The universe protects the speed of the light. It guards that value, 299,792 kilometers per second, as if it were sacred. Nothing, no matter how fast it moves, can surpass it. But if you try, if you accelerate a spaceship or a satellite to incredible velocities, something strange begins to happen. Instead of allowing you to break the limit, the universe stretches the fabric beneath you. Your time slows down. Your journey takes longer. From the outside's view, but for you, it may feel normal. Your seconds grow longer. Your story slows, even as your motion speeds up. This isn't just theory. You experience its effects every day, perhaps without knowing. The GPS on your phone relies on a network of satellites orbiting high above the Earth. These satellites carry atomic clocks, ticking with almost unimaginable accuracy. But they are moving fast, and they're farther from Earth's gravitational pull. Both motion and gravity affect their experience of time. Left uncorrected, those differences would cause your GPS to drift by kilometers each day. But engineers account for Einstein's insights, adjusting the timing so that your directions remain true. Without relativity, your phone wouldn't know where you are. Think about that. An idea dreamed up over a century ago by a man imagining riding a beam of light now silently shapes your morning commute. The same laws that govern starlight bending around galaxies also help you find the nearest coffee shop. Science isn't always grand explosions or glowing lab equipment. Sometimes it's just precision, subtlety, time stretched and bent so gently you can use it without noticing. And the effect becomes more profound the faster you go. At walking pace, the dilation is too small to detect. On a plane, it's measurable but tiny. But aboard a spacecraft moving near the speed of light, the change becomes extreme. You might travel to a distant star and return, having aged only a few years, while everyone on Earth has lived through decades. This is not a story from science fiction. It's a direct consequence of motion and time. It's sometimes called the twin paradox, though there's no paradox at all once you understand how frames of reference work. To move quickly is to stretch your timeline. You don't feel it, because your own clock ticks at its usual pace. But to the rest of the universe, you're lingering, drifting slowly through time while space whips past. Your seconds are not my seconds, and there's no right clock. All of them are correct, within their own motion, within their own frame. Time becomes personal. This thought, if you let it settle, can be strangely comforting. It means the universe is not ruled by an absolute tick-tock. It's a patchwork of timelines, each stitched into the motion of the object it belongs to. Your experience of now is your own, and it is shaped, quietly, continuously, by how you move. Even your heartbeat, your aging, your dreams, if you were flying fast enough, would stretch with you. From the outside you'd look slower, but from within you'd feel just the same. This isn't illusion, it's relativity, a law as natural as gravity, written into the structure of space-time. And perhaps that's why we sometimes feel that time moves differently when we move, when we're in transit or travelling far or watching the world speed by through a window. There's a scientific truth behind the poetry. Motion does change time. The world moves beneath your feet and time moves with it, folding and unfolding like fabric under wind. So the next time you glance at a clock or watch a plane trace its path across the sky or see a satellite gliding overhead, remember that those machines are not just moving through space, they're aging differently. Their seconds are tilted slightly, their pace a little softer, and you, standing still, are moving too. The Earth spins, the planet orbits, the galaxy spirals, and with each motion your timeline weaves into others. You're part of a web of ticking clocks, none of them wrong, all of them singing their own rhythm. The clock doesn't always tick evenly, but it ticks, softly, curved by motion, made strange by speed, and always, always guided by the light that never bends. When you think of gravity, you might imagine a force, a mysterious tug that pulls apples from trees and keeps your feet on the ground. For centuries, that was the accepted story. Gravity was thought to be an invisible hand pulling everything downward or inward. But then light came along and showed us something gentler, something stranger. It revealed that gravity isn't a force at all, not in the way we once imagined. It's a curve, a softness in the fabric of space and time itself. Imagine space as a kind of stretched sheet, soft, flexible, invisible. If you place a marble in the centre, the sheet dips slightly. Place a heavier ball, and the dip becomes deeper. Now roll a smaller marble nearby, and it curves toward the heavier one, not because it's being pulled by an invisible string, but because the surface itself is bent. The marble is simply following the curve beneath it. That is gravity. Not a force from afar, but a bending of space itself. And this, light tells us, is true even for things that don't have mass. Things like photons. You might wonder how something with no mass can be affected by gravity. After all, gravity pulls on mass, doesn't it? But Einstein showed us that light doesn't need to be pulled. It simply follows the curves. When space bends near a massive object, like a planet, a star, or a black hole, light bends too. It takes the curved path because that's what straight lines look like in a warped world. This bending isn't metaphor, it's visible. We've seen it with telescopes, photographed it, measured it with exquisite precision. It's called gravitational lensing, and it's one of the most quietly breathtaking sights in astronomy. Sometimes a massive object sits directly between us and something far away. A galaxy, a quasar, a flickering cluster of stars. As the light from the distant object passes by the massive one, it curves. Not sharply, not dramatically, but gracefully, like wind flowing around a tree. And by the time that light reaches us, the distant object appears distorted, duplicated, even ring-shaped. These glowing circles are called Einstein rings, not out of arrogance, but because he predicted them before anyone had seen them. They are the result of light taking every curved path around the massive object and arriving at our eyes at once, forming a symmetrical loop. In truth, the galaxy is still a single shape, but to us, its image has been bent into something more poetic. Gravitational lensing allows us to see things we might otherwise miss. Sometimes, it magnifies faint galaxies too far away to detect on their own. Sometimes, it warps and stretches their shapes into long arcs. In either case, it reminds us that what we see is not always what is. Light takes the long way, the scenic route, and it carries with it not only information but distortion, delay, and beauty. This bending doesn't just affect space, it bends time too. The closer you are to a massive object, the more time slows down. A clock near a planet ticks more slowly than a clock far away. This has been measured directly, with atomic clocks placed at different altitudes on Earth. The higher one, farther from Earth's mass, ticks faster. The lower one, closer to gravity's well, ticks slower. Again, the change is small, but real. In deep space, near neutron stars or black holes, this effect becomes profound. Time stretches dramatically. What seems like a few seconds to an astronaut falling toward a black hole might feel like hours, or days, or even centuries to someone watching from far away. Light reveals this by shifting its frequency. Climbing out of gravity's grasp takes energy, and that makes the light redder, slower, stretched. This is called gravitational redshift, and it's yet another quiet signal that time is not as rigid as it seems. Light once again becomes our guide. It shows us the warp and weft of space. It carries the curve in its path, the delay in its arrival, the stretch in its colour. And it does all of this not noisily, not abruptly, but softly, like water following the contours of a stream bed. We often imagine the universe as a vast grid, straight lines, even ticking clocks, regular orbits. But that is an illusion. The truth is curved. Everything is bending. Every second, every distance, every beam of light is shaped by the mass around it. And we are not separate from that curvature. We live in it. We age in it. We dream in it. Think about what that means. The light from a star may take thousands of years to reach us, curving gently around other stars and galaxies along the way. When you look up at the night sky, you're not seeing objects in place. You're seeing journeys shaped by the terrain of space and time. You're watching a light that bent, paused, and danced to get here. And it got here. That's the miracle. The light from stars has threaded its way through warped space, endured delays, and arrived at your eyes. It tells you not just what's out there, but how the path to here was shaped. It lets you read the shape of gravity with your gaze. You don't need to be an astronomer. You just need to look, because every star in the sky is not just a point of light. It's a memory, softly distorted, sweetly delayed, but true. Gravity doesn't pull. It shapes, and light, ever faithful, follows. At the edge of understanding, there is a place where light hesitates. It rushes toward it, always at full speed, never faltering, never aging, and then it stops. Not because it ran out of energy, or because something blocked its path, but because the very fabric of space and time folds in such a way that continuing forward becomes impossible. This place is called the event horizon, and it marks the boundary of a black hole. It's not a wall, or a surface, or an object. It's a shadow shaped not by darkness, but by the absence of return. Once light crosses that threshold, it never comes back. From the outside, it appears to vanish, slowly, silently, as if fading into a story that can no longer be told. To understand why this happens, we have to return again to gravity, not as a force, but as a curvature. In the presence of a massive object, space bends, time slows. We've seen that already, but with a black hole, the bending becomes so extreme that all possible paths through space lead inward. It's not that something is pulling you in, it's that the ground itself is sloping so steeply, so infinitely, that every direction points down. This isn't like falling into a pit. It's like trying to walk away from a whirlpool while standing on ice. You slip, slowly at first, then faster, until no path leads out. And for light, which always travels at the speed limit, this is where the path simply ends. Not in distance, but in possibility. If you were to stand at a safe distance and watch someone fall toward a black hole, you'd see something strange. They would appear to slow down. Their motion would stretch. Their signals would become redder, softer, more delayed. From your vantage point, they would never quite cross the event horizon. They would freeze, suspended in time. Eventually their light would fade into blackness, not because it stopped shining, but because it could no longer escape. From their perspective, though, if we imagine a person falling freely, unresistingly, they would not notice the event horizon at all. They would pass it in silence. There is no bump, no line, no flash, just the continuation of falling inward, deeper, into a place where time and space fold in on themselves. This difference between what is seen from the outside and what is felt on the inside is one of the strangest aspects of black holes. It reveals something profound about time. It is not the same for everyone. It depends on where you are, how fast you move, how much gravity surrounds you. At the event horizon, time for the outside world appears to stop. But from the inside, time marches forward, unknowable, uninterrupted. This boundary, this invisible, one-way surface, isn't made of matter. It's not a physical object. It's a horizon in time itself, the point at which all future paths lead inward. Light cannot escape it because light has no path out. And if light cannot leave, then neither can information. Neither can cause and effect. This is why black holes appear black, not because they swallow light, but because they seal off the future from the outside world. Yet, strangely, we can still detect their presence. We see the way they bend light around them, the way they tug on stars, the way their immense gravity sculpts the orbits of things nearby. Most recently, we've even seen their silhouette, a soft ring of light encircling a shadow, captured by the Event Horizon Telescope. It's not a photograph in the usual sense. It's more like a portrait of absence, a glimpse of where light could no longer go. That image was one of the most haunting ever taken, not because it showed violence or mystery, but because it revealed the shape of the invisible, a hole in space outlined not by itself but by the light it failed to hold. There's something poetic in that. We often define things by what they do, what they are, what they offer, but a black hole is defined by what it hides, what it removes, what it silences, and yet we know it's there. We feel its presence through the curves in space, the timing of pulses, the bending of starlight. In a way, it's one of the most observed unseeables in the universe. And still, the question lingers. What happens beyond the event horizon? The honest answer is, we don't know. Not because we haven't tried to guess or to calculate or to simulate, but because by definition, we cannot know. Nothing comes back. No information returns. The laws of physics themselves begin to blur near the center, where density becomes infinite and our equations break down. It's not just that the answers are missing, it's that the questions themselves start to dissolve. Still, black holes teach us something invaluable. They show us the limits, not of nature, but of knowledge. They remind us that even light, the fastest and most constant messenger in the universe, has places it cannot go. That even time, so fluid and flexible, can bend until it breaks. That space itself is not a backdrop, but a living fabric, one that can stretch, twist, and fold so tightly that paths simply vanish. And so, when you hear the term black hole, don't think only of destruction or collapse. Think of a pause in the story, a quiet silence where information stops flowing. Think of it as a punctuation mark in the sentence of the cosmos, a moment where the script disappears and all that remains is the question, what lies beyond? Maybe one day we'll find a way to learn more. Maybe quantum theory will offer a door where relativity closes one. But for now, black holes remain soft, silent, unknowable, and yet entirely real. The shape of a black hole isn't just a sphere, it's the outline of where time ends from one side. From the other, perhaps, time just begins again. The next time you look up at the night sky, perhaps while lying beneath a blanket or waiting in the hush between dreams, try to remember this. Everything you see is old. The starlight that touches your eyes tonight is not happening now. It happened long ago. Some of it began its journey before you were born, some before the first cities, some before there were humans at all. To look at the stars is not to see the present, it's to witness the past, still arriving. In a sense, we live inside a kind of light echo, a shimmering memory of things that once were. And though that may sound poetic, it is also quite literally true. Light travels at a finite speed. It may be the fastest thing in the universe, but it still takes time to get from one place to another. And the universe is large, unimaginably large. So the light from a star 10 light years away took 10 years to reach us. The glow of a galaxy 1 billion light years away began its journey 1 billion years ago, before Earth even had multicellular life. You're not seeing what that galaxy is, you're seeing what it was. It's a strange realization, isn't it? We think of vision as something immediate. We open our eyes and the world appears. But on cosmic scales, sight is delay. Even the sun, the closest star to us, shines with an 8-minute delay. If it vanished, we wouldn't know until those last photons arrived. And yet, this delay is a gift. It means that the universe carries its own record. It means that every point of light is a story, frozen in transit. We don't need to imagine the early universe. We can see it. We're surrounded by light that has been travelling for millions, billions, even more than 13 billion years. We're not just observers of the present. We're archaeologists of light. Some galaxies are so distant that we're seeing them as they were when they had just begun to form. Their light, stretched and faded, still finds us across the gulf of space. Through powerful telescopes, we peer into that light and reconstruct their early structure, their collisions, their births. It's like reading the childhood diary of a grown world. And then there's something even older, something fainter, something everywhere. The cosmic microwave background, or CMB, is the oldest light we can detect. It is not from a star or a galaxy, but from a time before those things existed. About 380,000 years after the Big Bang, the universe cooled just enough for light to travel freely. Before that, it was opaque, filled with hot plasma that scattered every photon. But once atoms formed, light could finally move in straight lines. That ancient light has been travelling ever since, and it still fills the cosmos. Today, we see it not as visible light, but as microwaves, low-energy photons stretched by the expansion of space. It comes to us from every direction, almost perfectly uniform, like a gentle whisper that wraps around the universe. It is the afterglow of the beginning, the soft light of birth, and it holds within it the fingerprints of that early moment. Tiny fluctuations in temperature, density and motion that later grew into galaxies, stars, and eventually us. When you lie down under the sky, you're not just looking outward. You're immersed in a story that began 13.8 billion years ago. A story written in light. Every photon is a message. Some are young, from nearby stars reflected off the moon, flickering from a street lamp. Others are ancient, launched before Earth's crust had hardened, before the atoms in your body had ever been forged. And all that light is still arriving, softly, constantly, quietly. That's the thing about photons. They don't age in the way we do. They are born, they move, they arrive. They do not experience time. For them, the journey is instantaneous. A photon launched in the first second of the universe is just now brushing your retina, and from its own point of view, it never waited at all. You, on the other hand, have been waiting. Not consciously, of course, but your body, your world, your place in the story, all of it has been arranged so that you could witness this moment, so that this ancient light could find you. There's something gentle about that thought, that you're not separate from the past, but part of it, that the universe is not done speaking, but still telling its tale, one slow photon at a time, and you are here to listen. Sometimes, when the night is quiet enough and the sky's clear, you can almost feel it, that soft, ever-arriving glow, not dazzling, not urgent, just present and old, so very old. You live inside a glow that began before time had teeth, before stars had numbers, before there was an earth to catch it, and it hasn't stopped. It won't stop. The sky's still full of light, still full of stories, still full of memory, and every night it arrives again. Astronomy, at its core, is not just about looking. It's about waiting. It is the quiet patience of watching for something that began long ago to finally reach you. Each telescope, each mirror, each lens pointed skyward is not simply an eye. It is a clock, tuned to an ancient rhythm, waiting for light to finish its journey. The universe is vast, so vast that even light, the fastest traveller we know, takes time to cross it. Some of the stars you see in the night sky are already gone, their light still crossing the distance between what was and what you now see. Their final glows are still in flight, unaware that their source has vanished. That is not sadness, it's poetry. It means we are surrounded not by death, but by arrival. Light still coming, story still finishing. When astronomers study the sky, they're reading a layered book. The deeper they look, the older the chapters become. A nearby star might be a recent note, a recent breath of brightness. But beyond that, hundreds, thousands, millions of light years beyond, lie galaxies whose photons began their path before humans even imagined fire. Light that left before Earth had oxygen, before bones, before thought. Every distant object we observe, every supernova, every shimmering burst of gamma rays, every ghostly spiral is a kind of delayed greeting. Some of these events are dramatic, stars collapsing into black holes, throwing off brilliant, brief flashes of energy. Others are slow and constant, the pulsing of variable stars, the dim glow of far-off clusters. But no matter their nature, they all share this. By the time their light reaches us, what they once were has already changed. And so, astronomy becomes a discipline of reverent delay. Telescopes do not just look, they wait. Even the newest, most powerful instruments are still bound by that truth. They open their sensors and gather the arriving past. A supernova that flared 5 billion years ago may light up our telescopes tonight. Not because it happened now, but because now is when its light arrives. The James Webb Space Telescope, orbiting in silent darkness beyond the moon's glare, is one such timekeeper. It peers deep into infrared light, catching the faint warmth of ancient stars. Its mirrors are tuned to see the oldest things, the galaxies forming when the universe was young, when hydrogen swirled into the first structures. What Webb sees is not the beginning of the universe, but its early adolescence, a universe still unsure of its shape, still trying to form. To say that the night sky is a time machine is not a metaphor, it's a description. Each photon carries a timestamp, not on its surface, but in its distance, its delay, its long, quiet flight. Light doesn't arrive instantly, it arrives late, and that delay is what allows us to see the universe not as it is, but as it was. And yet, even as we wait, the photons keep coming. Night after night they slip into our atmosphere, bend slightly through the air and meet our eyes or our instruments. Most of them go unnoticed. They strike rooftops, deserts, oceans, eyelashes. They are absorbed, scattered, or forgotten. But some are caught, captured by mirrors curved to the sky, recorded by digital sensors or photographic plates. When astronomers examine these faint signals, they don't just analyze, they listen. They decode the light's color, its angle, its flicker. From those details, they reconstruct the scene. How far the galaxy lies, how old the light must be, what elements the star contained, how fast it's moving. Light, after all, is full of stories, not because it speaks, but because it remembers. Consider a gamma-ray burst, the most energetic explosion known. It can release more energy in a few seconds than our sun will emit in its entire lifetime. When such a burst is detected, it is a relic, a flash that occurred in a galaxy millions or billions of light years away. It may have happened when Earth was still a molten sphere, but its light, persistent and precise, arrives at last bearing witness. And that's the strange beauty of it. The universe is not done, not yet. There are still photons en route, still travelling, still making their way across the vastness. Every second, light from unseen events continues to approach us. Somewhere, at this very moment, the light from a galaxy's birth is just reaching the halfway point on its journey to Earth. It may take another billion years, but it is on its way. This endless arrival gives astronomy its character. It is not about instant gratification. It is about long patience, about the joy of catching echoes, about waiting quietly, while the cosmos continues its long, slow breath. It teaches us something gentle. Not everything is meant to be known now. Some things are still travelling. Some truths are still in transit. Some light, some clarity may reach us only after great time has passed, but when it does, it will arrive exactly when it should. Not early, not late, just finally. So tonight, if you glance at a star and think it looks old, you're right. And if you close your eyes and imagine the light still to come, the stars yet to shine, the photons still in flight, you're seeing the future wrapped in the past. The sky is not fixed, it is unfolding. And you, dear listener, are part of that unfolding. You're not just here, you are being reached. If you were to hold a thread of starlight between your fingers, a strand of colour plucked from the blackness of space, you might expect it to stay still, neat, unchanging. But in the quiet, invisible stretch of the universe, that thread would begin to pull. It would lengthen, soften, redden, not because the light is growing tired, or because the star itself is moving away, but because space itself is stretching. The starlight isn't changing on its own. The path it follows is getting longer. This is the essence of cosmic redshift, one of the gentlest and most profound signs that the universe is not static, but expanding. As space stretches, it pulls on the light travelling through it. The wavelength, the length between each ripple of light, gets longer, and longer wavelengths mean redder light. A galaxy that emitted bright blue light billions of years ago now appears deep crimson, not because it lost its energy, but because its message has been softened by the journey. Redshift is not just a shift in colour, it is a shift in meaning. It tells us that the universe is growing, not like a balloon filling with air, but more like a sheet of bread dough rising slowly in the oven. Everything moves away from everything else, not because it's being pushed, but because the very structure of the cosmos is changing. This discovery, made in the 20th century and now fundamental to our understanding of cosmology, changed everything. It revealed that the universe had a beginning, a time when all things were close together, hot, dense, young, and now we know that it has a direction, a slow outward drift, an unspooling, and that means something extraordinary about the light we see. It is not just old, it is stretched, elongated, worn smooth by distance. The further away the galaxy, the more redshifted its light becomes, and that redshift acts like a map. It tells us not only how far away something is, but how far back in time we're seeing it. Telescopes like the James Webb Space Telescope are designed specifically to catch these stretched signals. They peer not into visible light but into infrared, the realm of the softened, the delayed, the realm where galaxies glow not like lanterns but like embers. This light isn't bright, it's not immediate, but it carries within it the whispers of a younger cosmos, and the expansion hasn't stopped. Even now, space continues to stretch. Distant galaxies race away from us faster than they once did. In fact, the expansion is accelerating. A mysterious force called dark energy seems to be pushing the universe apart with increasing speed. We don't fully understand it, but we can see its effects in the redshift. The glow of galaxies thinning, softening, sliding further into the deep red, and eventually into wavelengths too long to detect at all. That future is not far-fetched. In billions of years, the light from many galaxies will be so stretched, so faint, that it will slip beyond visibility. The sky, now full of stars and swirls, will grow darker, not because the stars have gone out, but because their light has gone too far, too slow to keep up, too red to be seen. The night will begin to forget. And yet, even in that forgetting, something beautiful remains. Because redshift is not a flaw, it's a recording. It means the light still exists, still carries its message, just in a different key. It's like a song played slower, deeper, in a lower octave. You can still hear the tune if you listen carefully enough. For now, we still live in a universe full of light. There is still warmth in the red, still structure in the glow. We still receive photons from the early galaxies. We still read the sky like a page. But we are living in the middle of the sentence, the part where the letters begin to fade, and one day, in a distant epoch, the page will continue turning, but the ink will be too faint to see. This doesn't mean the universe ends, it just means it gets quieter. In a way, it's like sitting by a campfire that's slowly burning low. The flames were once bright, crackling with energy, sending shadows dancing on the trees. Now the logs are ash, the glow is soft, and the only sound is the hiss of coals. But the warmth is still there. The memory of fire lingers, and in that soft fading, there is peace. Astronomers sometimes call this the dark era, a future where most of the stars have died, where the light is stretched too far to see, where galaxies slip past the edge of visibility. But for now, that moment is far away, and even then we suspect the universe will still whisper, through neutrinos, through black hole radiation, through low quiet vibrations in the structure of space itself. The story won't stop, it will just slow to a hum, and here you are, now, alive, in a time when the sky still tells its story in colour, when light from the beginning still finds you, when redshift is not silence, but softness. You are living in a window of cosmic readability, a brief span when the universe is still bright enough to be read. So the next time you see a red star, or look at an image of a galaxy glowing in infrared, think of it not as dim, but as aged, matured, a note stretched by time still carrying its tune, and listen, because the light is still arriving, still expanding, still singing. You don't really see with your eyes, not completely. What you call sight is a reconstruction, an interpretation, assembled quietly and invisibly by your brain. When light hits the surface of your eye, it doesn't form a picture. It begins a journey. Photons, tiny particles of light that have travelled for billions of years or maybe just milliseconds, pass through the clear outer lens of your eye and strike the retina. There, they're absorbed by specialised cells, rods and cones, that convert this soft impact into electrical signals, and then, like a whispered message, pass through a long hallway. Those signals move into your brain, into your visual cortex, where they are transformed into something else entirely, experience. But it doesn't stop there. What your brain delivers to you isn't a raw feed. You don't see photons. You don't see the actual world. You see a version of it, coloured by memory, shaped by emotion, filtered through the expectations and associations you've built across a lifetime. The light that entered your eyes is only the beginning. The rest, the sensation of a sunset, the feeling of a warm lamp in winter, the flicker of candlelight on a familiar wall, that is your mind, building something from light. Think of the way a certain colour can carry a memory, how the pale yellow of afternoon sun might remind you of a room from childhood, how the harsh blue of fluorescent lighting might summon a school hallway, a hospital, or a sleepless night. These aren't random associations. They are the architecture of your inner world. They are the result of light, once seen, becoming memory. Light is not just what lets you see. It's what you remember, and sometimes it's what you miss. Walk into a room with dusty shafts of sunlight, and you may feel something soft unfold inside you, not because of the shape of the room, but because the light feels like something, like a time, like a person, like a place you can't quite name. In this way, you don't just see light, you carry it, you recreate it, and your brain does this constantly, filling in blanks, adjusting contrast, heightening what matters and fading what doesn't. You might believe you're observing reality, but really you're observing your own inner cinema. The world you think you see is always being edited in real time by the director behind your eyes. Scientists have found that vision isn't just passive reception, it's predictive. The brain guesses what it's about to see based on context and fills in gaps using memory. That means when you look at a scene, you're not just reacting, you're remembering forward. The light becomes part of a continuous loop between past and present, sensation and story. This is why emotion can change what we see. If you're joyful, the world looks brighter, not metaphorically, but literally. Studies show that emotional state can affect contrast sensitivity and colour perception. When you're anxious or afraid, shadows seem darker, movement seems faster, light becomes sharper. Your inner weather colours the light outside. And time too plays a trick here. In moments of awe or danger, time feels like it stretches. In repetition or boredom, it contracts. But light plays along. A slow afternoon sun can feel endless. A flashing strobe in a dark room can make seconds feel like hours. Your experience of light is always entangled with your experience of time. Neither arrives alone. Sometimes a single beam of light, caught in the steam above your tea, reflecting in someone's eyes, slanting across a wooden floor, can pull you instantly into a memory. Not just a thought, but a feeling. A full-body return. These are not hallucinations. They are the gentle consequence of a brain built to learn from light. Your memories are full of brightness and shadow, and often it is the lighting of a moment, more than the words or actions, that defines how it's recalled. Think about photographs. Black and white images feel distant, historic. Sepia tones feel nostalgic. Harsh fluorescent glare feels sterile, even if the subject is joyful. Light sets the tone. The memory remembers the lighting, not just the content. And then there are those moments when the memory of light becomes so strong that you close your eyes and see it again. Not as it was, perhaps, but as it felt. A sunlit kitchen, a golden field at dusk, the flicker of a screen in the dark. Your brain doesn't need the photons anymore, it keeps the glow. Somewhere in the folds of your neural pathways, light is stored, recalled, whispered back into shape, not because it is necessary, but because it is beautiful, because it meant something. You are, in this way, a kind of lantern. You receive light, you reflect it, you remember it. And when the world goes dark, when night falls or dreams come, you still carry a little glow. Inside your thoughts, behind your eyes, the photons are gone, but the impression remains, and so, even if the universe forgets what once shone, you may still remember. Even if the stars go quiet, their echoes flicker on your internal screen. You don't just see light, you remember what it meant to you. You like to think of yourself as living in the present, as seeing the world as it is, moment by moment, frame by frame. But the truth is more subtle. You don't live in the moment, you live in the memory of it. Every sound you hear, every flash of light you see, every word you read, they've already happened. By the time your brain becomes aware of them, they are part of the past. And yet, your mind builds a seamless now, one that feels whole and instant, like a beam of light. But light is fast. Your brain is not. There is a delay, slight, imperceptible, but real. Neuroscientists estimate that it takes your brain approximately 0.2 of a second to process sensory information and turn it into conscious awareness. That's about 200 milliseconds. In that time, photons have travelled 60,000 kilometres, nearly around the Earth and back, and yet your brain has only just begun to notice them. You never see the world directly. You see it slightly behind, like a broadcast on a time delay. To make up for this, your brain is constantly predicting. It fills in the blanks, it adjusts, it compensates. You think you're seeing a tennis ball in motion, but your brain is actually calculating where it should be, not where it is. It anticipates motion, infers position, and then delivers a version of reality that feels instantaneous, but it never truly is. This delay is not a flaw, It's a feature. Your brain works with what it has, data arriving slightly late, signals slightly blurred, and it weaves them into a coherent now. That's why catching a ball feels natural, even though the ball is already past you when you see it. That's why music sounds smooth, even though your brain is decoding waves that have long left the speaker. But once you begin to notice the delay, you see it everywhere. In the way lightning is always seen before it's heard, in the lag between touching a hot surface and feeling the burn, in the strange moment when your name is called and you turn your head before realizing why. The present is never pure. It's always a blend of arriving data and internal guesswork, and sometimes the system glitches. Have you ever experienced déjà vu, that uncanny feeling that you've lived this moment before? One explanation is a misfire in the brain's timing, a brief confusion between immediate experience and short-term memory. Your mind tags the moment as familiar not because it truly happened before, but because the signal has looped strangely, making the present feel like a rerun. Or think about dreams, those vivid, non-linear, often nonsensical stories your brain constructs in the dark. Where does the light in a dream come from? You see flickering shadows, bright rooms, glowing skies, all while your eyes are closed. Your mind doesn't need real photons to simulate brightness. It uses memory. It uses imagination. It creates the illusion of light from the traces of what you've seen before. Dreams are light remembered, scrambled, stitched together. A private cinema where time loops and logic dissolves. In dreams, the delay vanishes entirely. There is no real input, no signal to process. Your brain is free to stretch and bend its own sense of time. Minutes can feel like hours. A full narrative can unfold in a few seconds of REM sleep. Some people report entire conversations, journeys, even lifetimes happening inside a single dream. These aren't lies. They're examples of what your mind can do when it's unbound from the rhythm of the outside world. And even when awake, your consciousness is never a live feed. It's a reconstruction, a narrative, a constantly updated version of now that's assembled from sensory fragments, emotional tones, and internal expectations. The philosopher Daniel Dennett called this the multiple drafts model of consciousness. Your brain is constantly revising, rewriting, editing experience before presenting it to you as a finished scene. But the edit is always late. There's something quietly humbling about this. That even your most vivid sensations are not happening to you, but through you. That what you feel, what you see, what you think is real is, in some small way, already over. The moment has passed, and yet you catch it. You hold it. You believe in it completely. The delay doesn't make your life less real. If anything, it makes it more beautiful. Because every experience is something the mind has worked to shape. Every image has been filtered, balanced, tuned like a song before you hear it. Your perception is not a camera, it's a performance, a carefully crafted illusion, tuned for meaning, not accuracy. And sometimes, that illusion is so good you forget it's even there. You walk through your day believing in the crisp edges of what you see, in the immediate pulse of what you feel. But beneath that seamless performance is a soft lag, a delay measured in milliseconds, a mind waiting for light and sound and touch to catch up. Still, you are here. Still, the story's being told. So the next time you notice something, the shimmer of leaves, the tap of footsteps, the light catching in someone's eye, remember, you are seeing a ghost of the present, a memory dressed in now. And that's okay, because the present isn't a point, it's a stretch, a soft, shimmering overlap of what just was and what is almost here. You don't live in the instant, you live in the glow just behind it, and in that glow, time slows, light softens, consciousness blooms. You're not a machine, you're a rhythm, a cycle of waking and sleeping, of rising alertness and gentle fatigue, of warmth and coolness, hunger and rest. Even when you sit still, Even when you do nothing, something inside you is ticking, a quiet biological metronome keeping time not with numbers but with light. Near the centre of your brain, nestled within the hypothalamus, is a tiny cluster of cells known as the suprachiasmatic nucleus, or SCN. It's no larger than a grain of rice, but it is your master clock. It tells your body when to wake, when to sleep, when to release hormones, when to eat, when to focus, when to feel. And this master clock is tuned, not by sound or heat, but by the arrival of light. Each morning, as daylight touches your eyes, even through closed eyelids, a signal is sent. The photoreceptors in your retina pass information not only to your visual cortex, but to the SCN, which reads the light and resets the clock. This is not metaphor, it is molecular. Your biology listens to sunlight like a conductor, listens to the first note of an orchestra. Light doesn't just illuminate your world, it synchronizes your being. This rhythm, known as the circadian cycle, spans roughly 24 hours. It's not exact, not without the help of the sun. Left to its own devices, your internal clock would slowly drift, gaining or losing minutes each day, but the rising and setting of light keeps it anchored. The pattern of dawn and dusk is not just beautiful, it is functional. It resets the heartbeat of your biology. Disrupt this rhythm and you begin to feel it. Jet lag is not just travel fatigue, it's a mismatch between your internal clock and the new light of a distant time zone. Your body still believes it is midnight while the city around you is waking up. Shift workers often face this in more subtle, chronic ways. Their sleep fragmented, their energy misplaced. Even the blue glow of screens late at night can confuse the SCN, tricking it into delaying melatonin release, making sleep feel distant and slippery. Light is not neutral, it sculpts your chemistry. It determines when melatonin begins to flow, signaling your body to prepare for rest. It sets the pace for cortisol, which fuels wakefulness. It influences your body temperature, your appetite, your mood. Depression, particularly seasonal depression, is often linked to insufficient exposure to natural light. In some cases, the cure is not medication but morning sunshine. And it's not just the timing of light, it's the quality. Blue light, abundant in daylight, is a powerful stimulator of the SCN. That's why it wakes you up. That's also why too much artificial blue light in the evening can make sleep elusive. By contrast, warm, dim lighting, like firelight or amber lamps, signals the body to slow down, to release melatonin, to sink into rest. What this means is profound and gentle. Your body is built to glow in harmony with the sky. You're not just reacting to the world, you're timed to it. When the light dims outside, something inside you prepares for quiet. When the light returns, something in you wakes before you even open your eyes. And this pattern is old. It is older than cities, older than books, older than artificial time. Before clocks, before calendars, there was only this: light and shadow, day and night, the slow turning of earth beneath the sun. And your ancestors moved with that rhythm, not against it. They rose with the warmth of morning. They rested when the fire grew low. Their chemistry followed the sky. And though the world has changed, your biology has not forgotten. Even now, in a world of glowing screens and 24-hour noise, your body listens for light. It notices the time of sunrise even if you sleep through it. It feels the late afternoon sun and begins to wind down, even if your mind says you must work longer. And when you spend a day indoors, never stepping outside, something in you grows quiet, not tired, but misaligned. The light didn't find you, and your inner clock ticks uncertainly, searching for its conductor. But there is a kindness in this too, because you can reset. Each morning offers a new calibration. A walk in early light, even on a cloudy day, can restore the rhythm. A warm lamp in the evening, soft and amber, can signal that it's time to let go. Light, when used gently, is medicine. It is alignment. It is a conversation between your biology and the turning of the world. And deeper still, perhaps there's something poetic in knowing that you carry this rhythm, not just as a biological necessity, but as a kind of music, that you're not separate from the world's passage, but joined to it, beat by beat. You are tuned, you are sung, you are a pattern of chemistry wrapped around a pattern of light. So tonight, when the day ends and your body begins to slow, you are not just tired, you are listening to ancient rhythms, to invisible clocks, to the lullaby that begins not with sound, but with the softest withdrawal of light. And when you wake tomorrow, as light returns to your skin, you're not just refreshed, you are realigned, you're relit, you're a being shaped by dawn. You don't just live with light, you're timed by it. If you could follow a single photon on its journey from the heart of a star to the back of your eye, it would seem like a long trip. Perhaps it began in the center of the sun, jostling and bouncing for tens of thousands of years before it even escaped into open space. Perhaps it left a dying star billions of years ago, flung across the expanding universe, and then, one quiet moment, it arrived, touched a leaf, brushed your skin, fell into your pupil and struck the back wall of your eye, leaving a signal that would become a colour, an image, a thought. And yet, from the photon's perspective, there was no time at all. That's the strange thing. Light moves at the cosmic speed limit, 299,792 kilometers per second, and at that speed, in a vacuum, something remarkable happens. According to Einstein's relativity, time stops for the photon. Its journey, no matter how vast, is instantaneous from its own frame of reference. A photon that left the Big Bang nearly 14 billion years ago and arrives in your telescope tonight hasn't aged. It hasn't waited. It simply is. You might call this paradoxical or impossible, but it's just the quiet nature of light. It is timeless not because it exists outside of the universe, but because it exists on the edge of what we can understand. It travels, and yet does not pass through time. It moves, but experiences no before or after. It arrives, but never remembers having left. And still, that photon changes everything. It is through light that the universe becomes visible. It is through light that structure is revealed, colour is born, meaning is suggested. Without light, there is no perception. Without it, no shadow, no contrast, no edge or surface. Light is the first invitation to be aware. But more than that, light is what made you possible. The atoms in your body were forged in ancient stars, yes, but it was light, flowing constantly from our sun, that turned those atoms into food, into heat, into motion. Light fed the plants, which fed the animals, which fed you. Light powered the reactions in your cells, firing neurons, moving muscles, building memories. You're not just made of stardust, you're animated by sunlight. And in some quiet way, you've continued the photon's journey. It struck your skin, it warmed your blood, it helped you walk, laugh, remember, create. A photon's path is short, but its story is long. Because once it touches you, it becomes part of something else, something slower, something that does move through time. You. You are, in this strange and beautiful way, the place where light learns to wait, the place where time begins again. The brain that receives light turns it into thought. The body that absorbs warmth turns it into action. The heart that beats in the sun's rhythm turns it into emotion. And though you cannot move at the speed of light, you carry its echo. You remember. You glow. Even now, as you lie still and prepare for sleep, photons flicker across your memory. The colour of morning on your bed sheets, the golden hour on a friend's face, the dim blue of a phone screen too late at night. These are not just recollections, they are internal light. the shadows and glows of everything you've seen folded into your mind. And when you sleep, light does not stop. It has simply passed its task to the brain. Dreams shimmer in its absence. You see scenes, people, places, but your eyes are closed. The photons are gone, and still the images come. This is the final magic of the photon, that even though it never experienced time, it gave time to you. It delivered you into the world of sequences, of memory, of growth. It helped build the chemical clock of your cells, the electric spark of your thoughts, the rhythm of your breath. And now, as the day ends and the light withdraws once more, it feels right to follow its example, to return to stillness, to become for a few hours timeless. Sleep then, little photon. Though you never waited, though your path was weightless and brief, you gave something that waits in us. You gave colour and story and warmth. Sleep, little traveller. Your journey reached us, and we remember.